Okay, good morning. The topic that I'm going to discuss today is the chi-square test. So this is a test of difference between the observed and the expected frequencies. The chi-square is considered a unique test due to its three functions, which are as follows. We have there the test of goodness of faith, the test of homogeneity, and the test of independence. For the chi-square test of goodness of faith, the test is applied when you have one categorical variable from a single population. It is used to determine whether sample data are consistent with a hypothesized distribution. This is a test of difference between the observed frequencies and expected frequencies, and this is the formula that we are going to use. We have their chi-square is equal to the summation of the observed frequencies minus the expected frequencies squared divided by the expected frequencies. For our first example, the theory of Mendel regarding crossing of P's is in the ratio of 9, 3, 3, and 1, meaning 9 parts are smooth yellow, 3 parts wrinkled yellow, 3 parts smooth green, and 1 part wrinkled green. The researcher conducted an experiment and the result was that out of 560 P's, 310 were smooth yellow, 100 were wrinkled yellow, 110 were smooth green, and 40 were wrinkled green. Is there a significant difference between the observed and the expected? So use chi-square test at 0.05 level of significance. So, for our problem statement, is there a significant difference between the observed or the actual experiment and the expected or theory frequencies? For our hypothesis, for the null hypothesis, there is no significant difference between the observed and the expected frequencies, or it can be written as HO is the observed is equal to the expected. Then, for our alternate hypothesis, there is a significant difference between the observed and the expected frequencies, or it can be written as HA, observed, is not equal to the expected. For the level of significance, we are going to test this at alpha is equal to 0.05. Okay? For the degrees of freedom, our H here represents the number of groups. Okay, since we have 4 groups, we have there 4 minus 1, that is equal to 3. And chi-square at 0.05 with 3 degrees of freedom is 7.815. This is our tabular value. For our computation, okay, so how are we going to compute for the expected value? So we are just given the ratio. So here, what we are going to do is to get the total of the ratio, okay, that is 9 plus 3 plus 3 plus 1, that is equal to 16. Then, we divide the total of the actual result or the observed values, that is 560, divided by 16, we have there 35. So, 35 for the expected frequencies is 35 will be multiplied by each ratio. 35 times 9 is equal to 315. 35 times 3 is 105. Then 35 times 3 is 105. 1 times 35 is 35. For a total of 560. Okay? So what is the next thing to do? We need to get the difference between the observed and the theory or the expected frequency or expected value. And then, we need to square it divided by the expected values. So here, for the smooth yellow, we have there 310 minus 315 squared divided by 315, that is 0.079365. For the wrinkled yellow, we have there 110 minus 105 squared divided by 105, we have there 0.238095. For the smooth green, we have there 110 minus 105, okay, squared divided by 105, that is 0.238095. And then for the wrinkled green, we have there 40 minus 35 squared divided by 35. We have there 0.714286. Then, we get the total of this, that is 1.269841. This is our computed value of chi-square. So for our conclusion, since the computed value of chi-square, that is 1.27, is less than the tabular value of 7.815 with 3 degrees of freedom, we fail to reject the null hypothesis. There is no significant difference between the observed and the expected values. Okay, so for example number 2, a certain machine is supposed to mix peanuts, hazelnuts, cashews, and pecans, okay, which is in the ratio of 4, 3, 2, and 1. A can containing 500 of these mixed nuts was found to have 270 peanuts, 110 hazelnuts, 80 cashews, and 40 pecans. So, at 0.05 level of significance, let us test the hypothesis that the machine is mixing the nuts at the ratio of 4, 3, 2, and 1. So we have, or we can make a table, okay? So this one is for the peanuts, okay? The hazelnuts, and then cashews, and then pecans, okay? So our ratio is 4, 3, 2, 1. Okay? So this one, the total is 10. For our actual or the observe, we have there 270, 110 hazelnuts, 80 cashews, and 40 pecans. Okay? So this is 500. Okay, then let us compute for the expected. Okay, so again, this is our observed, this is our expected value. So again, 500 divided by 10, we have there 50. Okay, so 50 times 4, we have there 200. Then 50 times 3, we have 150. 50 times 2 is 100. 50 times 1 is 50. Okay, so let us compute now for the observed minus expected squared divided by the expected. So we have 270 minus 200 squared divided by 200 is, we have 24.5. Then 110 minus 150 squared divided by 150, okay, that is 10.67. And then we have there 80 minus 100 squared divided by 100 is 4. And then we have there 40 minus 50 squared divided by 50. We have there 2. Okay? Then we get the sum. We have here 41.17. Okay? So this is our computed value of chi-square. So for our conclusion, okay, since the chi-square computed value of 41.17 is greater than or beyond chi-square at 0.05, which is equal to, again, we have 4 groups, that is 7.815, okay, with our degrees of freedom is equal to 3, we can reject our null hypothesis. Okay? There is, oh no, we can reject our null hypothesis. There is a significant difference between the actual or the observed frequencies or values, okay, and the theory or the expected values. Okay. Another example is the Acme Toy Company prints baseball cards. The company claims that 30% of the cards are rookies, 60% veterans but not all-stars, and 10% are veteran all-stars. Suppose a random sample of 100 cards has 50 rookies, 45 veterans, and 5 all-stars. Is this consistent with Acme's claim? Use a 0.05 level of significance. Okay. We have here our rookies, our veterans, but not all stars, and our veterans all stars. Okay? So for our observed, we have out of 100 cards, 50 were rookies. Veterans but not all stars are 45, and we have 5 all stars. Okay. So for our expected, since we are given the percentage for 100, 30% is, we have there 30. For our veterans, we have there 60, or 60% is 60. Then 5. Okay. So we have there 10 for the all-stars. Okay. Let us get the observed minus expected square divided by expected value. Okay. So we have here 50 minus 30 square divided by 30 is 13.33. 45 minus 60 square divided by 60 is 3.75. 5 minus 10 square divided by 10, we have there 2.5. Okay? Our total is, we have 19.58. Okay? So this is our computed value of chi-square. So for our conclusion, again, okay, so since the computed value of chi-square that is equal to 19.58 is greater than our chi-square at 0.05 with 2 degrees of freedom, that is 5.991. Okay, this is with our degrees of freedom is equal to 2. We have 3 minus 1, we have 2. We reject our null hypothesis that there is, okay, that there is no significant difference between them. So we have here, so there is a significant difference between the observed values or the actual and the claim of Acme or the expected values of Acme. Okay? Okay, next, chi-square test of homogeneity. For this one, the test is applied to a single categorical variable from 2 or more different populations. So it is used to determine whether frequency counts are distributed identically across different populations. Its data distribution are similar with respect to a particular criterion variable. We can use this formula, or we can also use our first formula, that is chi-square is equal to the summation of the observed minus expected squared divided by expected. It's just the same. Okay? For this one, we have evaluate the attitude of Lakas and Laban parties on the issue of peace and order in Mindanao. To carry out the study, a separate random sample of members of each party is drawn from the nationwide population of Lakas and Laban, and each individual in both samples responds to the scale. Scores are then classified into favorable or unfavorable categories. So the following frequencies are obtained. We have here, for the Lakas, 65 are favorable and 35 are unfavorable. For Laban, we have there 50 for favorable and 50 for unfavorable. Okay? So you have there, the total number of values is 200. Okay, so this will be our A, B, C, D, K, L, M, N. This is our N. So using the formula chi-square is equal to N times AD minus BC squared divided by KLMN, we have there 200 times, okay, 65. Okay, this is, yeah. We have here 65 times 85 minus 35 times 50 squared divided by 100 times 100 times 115 times 85. So that gives us okay, 4.603581. Okay. So since the for our degrees of freedom, we test this, let us say we are going to test this at 0.05. Okay, for the degrees of freedom here, we have our rows, that is, our rows is 2, our columns is also 2. We have the rows minus 1 times columns minus 1, that is equal to 2 minus 1 times 2 minus 1. We have there 1. So, at 1, okay, so for the degrees of freedom, that is equal to 1, our tabular value of chi-squared 0.05, at 1 degree of freedom, we have here 3.841. Okay, so comparing the two, okay, what will be our conclusion? Okay, so here, since our computed value of chi-square, that is 3.841, is less than the tabular value of chi-square, that is 0.05, that is 3.841, is less than the computed value of chi-square at 4.60351. Okay, so what will be our conclusion? We reject the null hypothesis. Okay, so here we can conclude. Okay. Computed value of chi-square, that is 4.603, okay, is greater than our chi-square at 0.05, that is 3.841, okay, with degrees of freedom is equal to 1, we reject HO. By the way, what is our null hypothesis here? Their responses are not homogeneous. Okay? So, of course, our HA, the responses are homogeneous. So, here, we reject our null hypothesis. Their responses okay? So, for example, number 2, okay, in the study of television viewing habits of children, a developmental psychologist selects a random sample of 300 first graders, 100 boys and 200 girls. Each child is asked which of the following TV programs they like best: The Lone Ranger, Sesame Street, or The Simpsons. Results are shown in the contingency table. We have there, okay, the viewing preferences, and these are the gender. Okay, so for the boys, we have 50 are favorable to Lone Ranger, 30 for Sesame Street, and 20 for The Simpsons. For the girls, 50 are favorable to Lone Ranger, 80 for Sesame Street, and 70 for The Simpsons. Okay? So our N is 300. So here we can use our formula chi-square is equal to the summation of, okay, observed minus expected squared over expected. Okay, since we have here 3 columns. Okay, so for the, how are we going to compute for the expected values? Okay, so here, we have here the boys, the girls, okay. So let's say this is the Lone Ranger, observed values. This is for the expected values. The Sesame Street, okay. And then we have here The Simpsons, okay. So for the Lone Ranger, we have 50, 50, we have there 100, okay. For the total, this is for the total, we have 100, 200, grand total of 300. For the Sesame Street, we have 30, again 80, this is 110. For the Simpsons, we have there 20, we have here 70, this is 90, okay. So let us compute for the expected values. So we have here TL expected, SS expected, and TS expected. Okay, so how are we going to compute for this value? We have here, for this one, that would be 100 times 100 divided by 300. Okay, so that is how you are going to compute for the expected value. We have here 33.33. For this one, we have there 100 times 200 divided by 300. So that is 66.30, oh no, 67. Okay, so again, it gives us a total of 100. For this column, we have there 110 times 100 divided by 300. It gives us 36.67. Okay, so for this, we have 110 times 200 divided by 300. We have there 73.33. Okay, it gives us 110. Okay, the next is we have 90 times 100 divided by 300. We have there 30. And then 90 times 200 divided by 300. We have there 60. And this is 90. Okay? Then, we get the, of course, again, the summation of, okay, chi-square is equal to the summation of observed minus expected squared over expected. Okay? So that is equal to the observed minus expected squared over expected. We have 50 minus 33 squared divided by 33.33. We have 8.33 plus 50 minus 66.67 squared divided by 66.67. We have there 4.17 plus 30 minus 36.67 squared divided by 36.67. We have there 1.21 plus, we have there 73.33 minus 70 squared divided by 70. We have there 0.606. Okay? Plus, okay, we have there 20 minus 30 squared divided by 30. We have here 3.33. Plus, okay, 70 minus 60 squared divided by 60, 1.67. Gives us a total of, we have 19.318. Okay. So, for the comparing it with the tabular value or chi-square at 0.05 with degrees of freedom, that is how many groups do we have or how many rows do we have? 2 minus 1, we have 1. How many columns we have? 3 minus 1, we have 2. So, 2 and 1, we have 5.991. Okay? So, again, comparing, the computed value is greater than the tabular value. So, meaning we can reject our null hypothesis. There is their preferences are homogeneous. Okay? Okay, so for the test of independence, so it is used to determine if there is a significant relationship between two nominal categorical variables. The frequency of each category for one nominal variable is compared across the categories or categories of the second nominal variable. The data can be displayed in a contingency table where each row represents a category for one variable and each column represents a category for the other variable. So again, we can use this formula. For our example, Super Vending Machines Company is to install soda pop machines in elementary schools and high schools. The market analysts which wish to know if flavor preference and school level are independent. A random sample of 200 students was taken or were taken. Their school level and soda pop preference are given in the next table. Is independence indicated at 0.01 level of significance? Okay, so let us compute. We have here our soda pop. Okay, we have Cola, Mountain Mist, Jungle Grape, Diet Pop. Okay, we have here our high school and elementary. Okay, so we are given the observe. Okay, how do we compute for the expected values? Okay, so again we have here. Okay, so we have here for this one 80 times 90 divided by 200. So that gives us 36. Then 80 times 50 divided by 200, we have there 20. Then 80 times 40 divided by 200, we have there 16. Then 80 times 20 divided by 200, we have there 8. For this one, we have 90 times 120 divided by 200, we have there 54. Then 120 times 50 divided by 200, we have there 30. Okay? And then we have 120 times 40 divided by 200, we have there 24. And then 120 times 20 divided by 200, we have there 12. Okay? Then, again, compute for the observed minus expected squared over expected value, and then we get the sum. Okay? So here we have chi-square is equal to, we have 0.25 plus 5 plus 7.5625 plus 2 plus 0.167 plus 3.33 plus 5.042 plus plus 1.33. Okay? So our chi-square is, we have 14.8125. Okay? So, our chi-square at 0.01, okay? What is our degrees of freedom? We have there, our rows is how many? Rows is equal to 1, 2, 3, 4. Okay, 4. Minus 1, we have 3. Our columns, how many do we have? We have 2. Minus 1, we have 1. So, at 3, our degrees of freedom is 3. We have there 11 point, at 0.01, 11.345. Okay? So here, our computed value of chi-square is greater than our tabular value of chi-square. So that only means that the null hypothesis is rejected. Okay? The preferences of students are independent. Okay? So that's all.